All right, here's that other video where we use SSS with the distance formula to prove it. I'll show you that example next. All right, here we go again. So remember what I started with. If I want to prove these two triangles congruent, I have to use side, side, side. So I got to prove the length of each side is congruent. So I'm going to start by finding the distance for AB. So AB is going to be the distance formula. Again, it's the square root of x. So here's x1, y1, x2, y2. So I'm going to go x minus x. 4 minus 1 squared plus negative 3 minus 2 squared. If I add the opposite, okay, then I will get 4 minus 1 is 3 squared plus negative 3 plus negative 2 is going to be negative 5 squared, and that's the square root of all this. 3 squared will be 9. Now negative 5 multiplied by negative 5 will be a positive 25. Remember, the two numbers underneath the radical that you add together will always be positive. And that's going to equal then the square root of 34. I could turn that into a decimal. If I wanted to, I'm going to leave it as that, because if I get exactly the square root of 34, I know I'm good. So DE, and I don't need a calculator. All right, so again, I could do x1, y1, x2, y2. So that's the square root. We're going to go 7 minus 4 squared plus 2 minus 7 squared. All right, well, 7 minus 4 is 3 squared plus, that'll be, again, add the opposite, so negative 5 squared. Well, again, I'll have the square root. That's going to be the square root of 9 plus 25, which would equal the square root of 34. So right here, I have discovered that this is exactly the same. So I have square root of 34 and square root of 34. So I have proven two sides are congruent. I'm now going to move on to BC and EF. So first BC, now BC would be right here, x1, y1, x2, y2. So BC is going to be the square root of 2 minus 4 squared plus 5 minus negative 3 squared, all over that. So that's going to be, if I again add the opposite there and add the opposite there, 2 plus negative 4, that's going to be negative 2 squared plus 5 plus 3 is now 8 squared. Square root of all that. Well, that's going to be then 4 plus 64, and that is the square root of 68. Again, you can turn that into a decimal if you'd like to. I'm just going to leave it as that for now. Now I got to check EF. So EF right here, x1, y1, x2, y2. That's going to be the square root. I will have 5 minus 7 squared plus 10 minus 2 squared. All right, add the opposite, 5 minus negative 7 would be negative 2 squared plus 8 squared. All right, looking pretty good here. That's going to be, again, 4 plus 64, which is then equal to the square root of 68. So square root of 68 is equal to the square root of 68. So I have another set of sides congruent. And I got to do the last set, which would then be to figure out what is AC. And so that was A and C. So then I would use D and F. So then DF. And AC, x1, y1, here's x2, y2. And AC, I'll take the square root of, it'll be 2 minus 1 squared plus 5 minus 2 squared. Well, that's going to be 1 squared plus 3 squared. So 1 plus 9, that is going to be the square root of 10. So I need to get the square root of 10 to prove congruence. And for df, I'm going to go with x1, y1, and x2, y2. Square root here, df is going to be 5 minus 4, that looks good, plus 10 minus 7. All right, well, again, I end up with 1 squared plus 3 squared. And that's going to be then the square root of 1 plus 9, which would equal, again, the square root of 10. So I have now proven here's the square root of 10 and the square root of 10. So they are congruent. So I don't have much space left, but I'll say yes. Let me get the actual pen, not a highlighter. Yes, comma, triangle ABC is congruent to triangle DEF. There's the work. So again, if you got a different number here or there, first make sure to check your work to see if there's any mistakes. And if they're not equal, I could have stopped after doing the distance formula twice. Or if this 68 didn't equal this square root of 68, again, I could have stopped after doing it 4 times. And if this one didn't equal this one, then I would say no, and it didn't work. But you got to go through the distance formula as many times as you need until you find something that is evident for sure. Hopefully this is helpful, and good luck on the assignment. Have a great day.